In this video, I'm going to go over the chi-square test of independence example that I referenced in my assumption video. And so I'm going to just simply walk through what I do to show how I'm dealing with the assumptions or I'm not dealing with the assumptions, and then walking through the hypothesis test itself. So what we have here is we're looking at sex and whether or not someone was vaccinated within that sex. So we've got men vaccinated, men not vaccinated, women not vaccinated, with a total number of 231. The hypothesis for a test of independence is the null is there is not a relationship between sex and vaccinations. In other words, saying that they're independent. The alternative is that there is a relationship between sex and vaccinations, that is to say they're not independent. The decision comes down to if the probability from the chi-square distribution is less than or equal to the alpha, which in this case will be 0.05, then reject the null hypothesis. And if the probability is greater than 0.05, then fail to reject the null hypothesis. If you're new to hypothesis testing, you always reference the decisions in relation to the null hypothesis. So you reject or fail to reject the null hypothesis. You never accept either one of those. Now let's get into getting that chi-square statistic. The first thing we need to do is get the expected values for the cells. The formula for finding that is the row number times the column number divided by n. For the first case, we have men that are vaccinated. So we look at this cell and we see that this is the column and this is the row. So we take 106 times 104 divided by 231. For men not vaccinated, we have 106 times 127 divided by 231 to get you 58.278. We do the same thing with women. So we have 125 times 104 divided by 231, and we have women that are not vaccinated, which is 125 times 127 divided by 231. So I'm going to stop here and we're going to go over the assumptions because I think right now, since we have all the information, we're able to adequately look over all the assumptions. So for the assumption 1, do we have categorical variables? Absolutely we do. We're looking at sex, men and women. We're looking at vaccinated or not vaccinated. They're mutually exclusive, their level, their frequencies, everything's good there. The second one is this randomly sampled? No, this is a fictional data set, so nothing's randomly sampled. That is an assumption you'll be able to check well before any of this analysis happens. And so you'll already know that, but just for the sake of going over all the assumptions that I said in the last video, I just wanted to spell that out. If it makes you feel better, this is fictional sampled data. The last assumption is going over whether or not the expected values for at least 80% of the cells are at least 5 or higher. All these values are well above 5, so in terms of this fictional data, it satisfies all the assumptions. The next is calculating the statistic with the information that we have. I'm just using the formula over here. And so we have men that are vaccinated, so I have 49 minus men that are vaccinated, 47.723 squared divided by the expected 47.723. So I do that for the rest. So we have 57 for the non-vaccinated men. For the expected value, it's 58.278, so I plug them in there. The next one is women that are vaccinated, which is 55 minus 56.278, and I plug in the appropriate numbers there. For the last one, it's looking at the observed of 70 and the expected of 68.723 and just applying that the same way. Here's also a reduction in terms of the calculation. It just so happened that all of them ended up being 1.278 or negative 1.278, which made the calculations fairly easy. And that's important to note that it's not always going to be the same. It just so happened to be in this situation it was. Finally, we have that this equals a chi-squared statistic of 0.115. The last part of figuring out how to get the chi-squared statistic probability is to know the degrees of freedom. And so we need to know what the formula for the degrees of freedom is. And so in this case, it's rows minus 1 times columns minus 1. So it's 2 minus 1 times 2 minus 1 since we had 2 columns and 2 rows, which gives us 1 for the degrees of freedom. The next is looking at what we already have, the calculated chi-squared of 0.115. From the chi-square table, it gives us a probability of 0.735. The next is that we have an alpha of 0.05, so a 95% confidence level. And we're going to compare that with what we have. From what we have is a p equals 0.735, our alpha equals 0.05, which means that p is greater than alpha, And so in this case, our decision is we fail to reject the null hypothesis that sex and vaccinations do not have a relationship. And in other words, saying sex and vaccinations are independent. If you found this helpful, please like and subscribe. I do plan on making more videos like this where I have an assumption followed by an example with that method. If you have any questions, please leave them in the comment section. I'll be happy to get to them. If you have any suggestions for methods or videos, maybe on topics, definitions, methods, please leave them there too. I probably have them in mind. It's just a matter of if you suggest them. That way I'll know what people are looking for. Thanks for watching and stay nerdy, my friends.